Okay. That's interesting. This feels strange, but that's all right. All right, so for anyone who's watching, because apparently there are people, I'm just making sure Optimus what is in, because he's basically the reason I started. All right. Yeah, so this isn't anything formal to any extent. Someone was just curious about sort of what I do. Oh, hey, apparently that is a thing. Is it? Oh, hey. Cool. Thanks, Phi. I was not aware. Yeah. All right. Okay. Damn, I haven't been on Twitch in like 2 years, 3 years, something like that. So I'm really, really rusty with anything. Yeah, so if Optimus What is in chat, just say hi, because essentially any requests for anything, and I'll like show it up. The other interesting thing too is that I'm streaming like work, which is different because I'm used to using both monitors, but obviously that's less exciting if I keep changing. So I have everything on like the one screen, but that'll be different. Yeah. Yeah, and I'm used to having like this stuff in a single window, like taking up a whole screen. So this will be interesting. So to preface, I guess, the last thing I've been working on recently is GMAs. So as far as I'm concerned, that's a game model archive. And it's got a bunch of stuff in it. Models, obviously. But as is tradition with most things, it's obviously not straightforward. It's quite special. And it's got some weird quirks. Some weird quirks. Yeah. So just because it's cool. Okay, so the colors are garbage. So I'll go fix that. I mean, okay, so I'm gonna just change this for now. like this is just all debug stuff. Different colors is just I can visually in my head understand and distinguish between two things. So I'm doing a couple of things right now. Oh, hey, Optimus, what? I'll have to like actually look in chat every so often. But yeah, so doing models. So that's what this scene is set up for. It's really just for checking out the models when I import. I got like this hacky little thing over here. Yeah, so basically what I have, if I go and look it up, is I got, here, let me organize this. Members. Basically, I've made this class and it gets an event, and with the event, it imports everything. So I get a GMA file, and then once I have it, I reconstruct it, which is this disastrous thing over here, and this other disastrous thing down here. This builds the mesh that you see. Yeah. So it does a couple of things, and there's a couple of things to note. So here, that's not even the right window. Okay, so HXD, hex editor, most everyone that does anything uses this. And okay, so one thing to note is that no one really ever does anything on their own, especially for this stuff. Even though I'm sort of the only one working on this project right now, there's at least like 5 other people that without them, I don't think I would not be where I am right now. So one of them is it Game Zelda? Something like that. He made a tool back in like 2011 and is sort of the reason I even have any of this stuff. And one of the things he made is he got the proper LZ decompression algorithm, so we can decompress all of the compressed LZ files in a GX game project. And these are all stages. Okay. Okay. Where did I put it? Assets, resources, GMA. So here, let's grab good old stage.lz. Okay, so these are, all right. So, oh, hey, Cypher, and Unreal. Oh my God, I can't talk. Yeah, so I'm just going over some stuff. So this is usually where anything that happens sort of starts. Right, so there's a couple of things. So this is a raw file. If you just open it up, what it looks like when it's serialized or saved, right? It's just like a raw binary stream of data. But we can do some things. For one, we byte group in chunks of 4. That's just because typically most things are saved in 4-byte chunks or aligned to every 32 bits. Which this file does do. And yeah, so normally when you start, this is what your project's going to look like. So there's a couple of things you can sort of spot right away, is that there's this big chunk at the start that kind of follows this, like, you know, there's a small number and another fairly small number. and then zeros, and then a big number and a small number, and then a bigger number and a small number, and an even bigger number. So once you get like familiar with code, you know that there's a couple of different things, especially when you save stuff. You have counts. So like if you have hexadecimal 10 of something, so 16, you know, that's a small number. That's like reasonable for an array of data. And then a big number, but a big number that is smaller than the file's maximum. So like the file, right, is hexadecimal 99,450. Right. And then you can kind of look that the last entry in this list is just below that at 99,000E0. You know, so you can start making some assumptions like, okay, that's probably a pointer. This is probably, maybe it's a count, maybe not, because if you look at it, they keep getting bigger and bigger. So it might be another pointer or an offset, right? And that's actually what this is. These values here actually point to where in this it's being referenced. And basically all of these on the right hand side, it's great. It's great when you can see stuff like this, because it's very clearly the names of the objects, right? So you have C01, which is course 01, guardrail 01, right? And then, you know, course 1, guardrail 2, so on and so forth. Then you have course 1, road 1, and so on and so forth, with the last entry being the course 1 map. And then right after that, you get this thing, GCMF. And this one's pretty particular, in that basically it's like a little magic identifier. In a lot of files, usually the first 4 to 8 bytes usually is a magic, what's called magic. Basically, it's an arbitrary constant that you choose to identify the file. So for instance, let's see. Textures, UI. Here, I'll open up a JPEG, right? So this FFD8, FFE1, if I were to copy, I'm gonna go into Google. It's pretty hilarious, because I just pasted this in, and the first suggestion is JPEG FFD8, FFE1, right? And that's how you can sort of tell it's the file signature, right? So there's certain things like that that usually get done. So basically a GCMF is that. It's one of these like magic identifiers. And then there's a bunch of data after. I believe it's these 3 lines. And then you have an array of texture identifiers that point to certain things. And again, that's like something that after enough time you kind of realize like certain things are incremental, like it's 0 and then 1 and then 2. And that's how many textures it's referencing. And we know this because if I open up Dolphin here, so in Dolphin, back in 2013, Cosmo Courtney found the debug menu for the Japanese version. It's not in the English version. And if you enter it, and then you go to stage, say stage 1, you have these things. So, right, it's like C01, guardrail 01, and then you have this NB underscore material, and NB underscore TL underscore material, which as far as I know is a translucent material, which makes sense because, hey, this is an alpha object, and it's the only texture referenced in this model, right? So that kind of a thing. It's just like things that you gotta infer. And then as you can tell, so you have 1 of 3, 2 of 3, and 3 of 3, right? And then again, if we go back to Let's gotta no. All right, now if we go back in here, the way code works is your black screen. Hopefully that went away. But the way counting works in code is that your initial object is 0. Oh, okay. Wow, that is strange. Okay, options, graphics, rendering. Options, graphic settings. Show FPS, log render time to file. Oh, wait a second. Options. Wait, options, graphics. Oh, okay. Strange, bizarre. All right, let me do this again. Sorry about that. There we go. That's fine. All right, so let me know if it still doesn't show up, but it should, right? Okay. So I'm gonna get out of here. There you go. I'll do this again. Right, so 2013 Cosmo Courtney comes across the debug menu. Super useful. So this is the model viewer that I'm in right now. So if you go to stage and you select the current stage, right, you can go through the different models. So again, right, like C01, guardrail 01, NB underscore material, NB underscore TL underscore material, so translucent material. There's one, none of the regular materials, and again, that's because the guardrail uses one translucent material. Right, so like things you can infer based off of name, and certain things that you sort of kind of guess. You have like this radius value, and that's to know, right, like this right here, what the radius of the object is, so you can properly view it. You know, if you go into the textures, you can see that it's like the first of 3, the second of 3, and the third of 3. And then that's sort of what let us really understand this file format. Again, you got the 0th index, the first, and then the second. Right, so it's like, okay, so we know that this here corresponds to this top texture. Right, so it has like 2 maps. It's in the CMPR format, and like a couple of other things, right? Like if I go up, right, you know, the wrap mode is 2 repeats, the map is a linear, right? And so these are values that actually get stored, sometimes in this file, sometimes in the other. This really just has a couple of values. I forget what they are. There's like somewhere in here is the aniso flag, so like anisotropic filtering, some constants, right? So anyway, certain things you figure out, and then it gets more complicated because like there's this here that's an identifier for all of the vertex strips, and then this is essentially this is actually oh my goodness, let me pull it up. libogc it's like vertex attribute. Yeah, okay. So that actually corresponds to this. So this libogc is an open source Gamecube library, and what it sort of does is it has a lot of the boilerplate code that you need to sort of set up a GameCube game and actually compile it. So there's the Vertex attribute array type, and it gives you all these things. And so define is just like, if I put this in, it'll return the value of 24. So basically what the actual values next to this, these are the bit layer index. So you can do things called like bit shifting and move bits around, and you can essentially, if you know what a Boolean is, like a true false, you can store 32 of them in an individual layer, and you use those as flags to tell, basically you're telling the GameCube graphics processor what data is coming up based on that. And that's what this is. If you look at this value in binary, it's like certain flags are on. So it has a position, it has a normal. And then once it's done reading all these things, there's, I forget which data type this is, but it's a 1 byte that's usually 0. And then, oh, what's that called again? I have this in my notes. If I go here, and then here. So I have this like giant spreadsheet, and it tells me everything. It's great. But that value is, do I not have it yet? I don't think I've written that far. Attribute slots. Yeah, I haven't written it down yet. It's somewhere else. But basically what it is like, it tells what type of format the data is structured in. So you can have like a triangle. So every 3 sets of data will make one triangle. But then you have triangle strips, and that's what the 98 stands for, hexadecimal 98. It just says like, you're going to read a whole bunch of triangles, and the first 3 will make a triangle, and then get rid of the first vertex, and then add a vertex, and then that's a triangle, and so on and so forth. And then this tells you how many triangles or how many bits of data are next, and then it reads like 1, and then 2, and then 3, and so on and so forth. On and on and on and on. And then once it's done, it'll actually have more of these, more types and counts, and it keeps iterating through. And it's a pain in the ass to keep track of. Right? But in a nutshell, when you start, you're just staring at this, trying to figure out like, oh, this might be this might point here, and then you like copy a value, and you like go to the address, and then you'll be like, oh yes, does this make sense? And right now it doesn't, right? But actually, if you go down, there's another GCMF here, because basically it's not actually a pointer in the file. It just says, hey, this is actually the size of the, because you'll see here, 01E0 is the same as down here, right? 01E0, and that's where the first entry is in this file. So if you add up this value with this value, you'll actually, well, I don't know why I'm even going down here. G, there we go. So then if you add, right, so if we were to add like 992E0, right, 992E0, and then you backpedal a tiny bit because we overshot it by 1 line, that's exactly where the GCMF is, right? So it's just weird stuff like that where you kind of have to be like, well, does this value with this value add up together? And then it's fairly easy to test because code has to be constant, right? So if that works for this value, that means it has to work for everything else. So you can test it. And if it does work for everything else, well, your assumption's been proven. Just a second, I just realized I've hidden chat, so I don't know if anyone's talking. Yeah. So right now we're looking at the GMA. So this is strictly just models. There's nothing more like here. Like, okay, so this is the viewer. So literally that's the job of this part of the debug menu, is to just look at models. So what you'll notice, for instance, if I do this, right, boom. So this is the track. And that's because these are all the stage models. So usually GX splits everything into two models. Usually you'll have only tracks. You'll have only tracks in these files. But that's not always true. Like you'll see this one all of a sudden has like a whole bunch of different stage things. But that's because they're specific to the stage. So if I go to 10, you'll see like it gets crazy, right? Like it's got the skybox and everything. As a matter of fact, if I turn this off, yeah. So, right? Okay, gotta. There's too much. Right. So you got like all your models in here for this one, and it gets kind of crazy, and it's also kind of confusing for most people, especially when you start off and you're like, why is everything overlapping? This is the model archive, which means that every model that's in here is basically either they all have an origin of 0, 0, 0, which means they're all overlapped, so that if you want to move it to somewhere else in the stage, you do. And then the model will go with it like accurately. Otherwise, if it's like a one-time model, it might be positioned exactly where it needs to be. And then you don't actually move them because you don't need to make duplicates. It's basically just if you offset the position, then it gets confusing because you'll be putting an object like in a spot and then it will be rendered somewhere else. And it could just, anyway, so that's what these are. And so that's sort of the general structure of how it works. So then what you have to do after that is, you know, it's an iterative process. So it's not like you just go in a file, you look at it and you're like, oh yes, now I know what's going on. You have assumptions about what the data is doing, and you can check for a lot of it. But the problem is you've just made assumptions, and your assumptions are probably going to be wrong in a lot of cases. And they have been for me. But usually it's like a good starting point. So in here, this is a script. So in C#, you can put things in a namespace. So I have f0gx data.file structures, and I have this class called GMA. And basically what I do is once, so I have this importer class. Sorry, I'm going to be jumping between a couple things. I have this importer class, and basically when the import function is called, so when in Unity, when I click on this import button over here, so here, let's go to serial caps. When I hit import, it imports this stuff. So what's going on is I hit that button calls this function that's called import, and it creates a new GMA. And what the GMA does is it gets a stream, so a file stream, from file name. And this is a little thing here where I have return format GMA, right? So I have, it's this little formatting thing, but basically what it does, it takes the number of the stage. So this is like this giant list. Each one of these stages has a value associated. For instance, green plant intersection is the 10th stage. So I've assigned it the number 10. So then in code, when I call it, it casts this enumerated type as a 10 back to an integer, makes that a string value of like in text format what that number is, and then sticks it in the slot. And then we go read that file. So that's how you get to the file. And then once it starts reading, this is what happens. I have this generic type called member, and I use it because it makes my life easy. But basically what happens is it calls deserialize. So the quick and dirty is serialize is the proper term for saving. So if you save data, like for a game or whatever, it's you're serializing that data. So deserialize means you take it out of you know, a data format that you put in, so like a file. So the first thing I do is I check some stuff. I set the reader so that it's like a class that lets me read data out of stuff really easily. And then I start reading data out of it. So I have this model count and then the header size. So those are the first two bits of data that we saw earlier here. It's reading this and then this. And then I start initializing some values. So I know that based on the model count, I can start saying like, okay, we're gonna have, I don't know, 20 models in this file. So I'll create a new array. So basically it's like a thing that holds many of the same thing. And then I start iterating on them. So for each of them, I know that I can start reading out a data address and then a name address. And that's what this is over here, a data address, a name address, then a data address and a name address. And I do that for this many times. And then I go into the model and then I start doing stuff. So in the model, I'll get the address, the name address, and the index value for it, and I'll store these. And then I'll set the reader again, go read it, and I'll start creating a GCMF, because I know that once I have, you know, these values, I can jump to, right, so like 0. So it's 0 plus this value. So I'll jump down here to the GCMF, and I'll start reading out this data. And so that's what it does right here. And then based on the GCMF data, I know how many textures there are, and I start reading that out, right? And it's just this continuous sort of one thing daisy chains into the next one, and then it reads this, and then it reads this, and then it'll read however many vertex strips there are, and so on and so forth. But basically what it means is I've written a class that has all the same data types, and I name it the same, or as close as I can to what I think it is, to those things. Right, so I have like this texture descriptor, vertex strip collection array, right? So this script itself is 917 lines with not enough comments. But that's essentially what you do, is you just write these classes, so like these containers, and then in them, so for instance, they're called members, right? So in the material descriptor, I don't know what the first value is, but I do know that the second one seems to be a lighting flag. I know that there's a byte eventually that's the vertex format. So basically, I just write out all of these things and then read them out at the appropriate time. And so if you're off by like a single byte, or if you don't read enough bytes or whatever, then your program just reads garbage, right? It starts reading the wrong values, and then it's like, well, you thought you needed to read 5 vertices, but it didn't align properly, so now you think that you need to read 78,000 vertices, and then that just leads to things like you'll get errors like, oh, you know, you can't make a model with more than 65,535 vertices, because that's the highest value you can fit in a 16-bit integer, right? So it's just like, so that'll happen, and then I'll go debug, and I'll set up my debugger and start poking at the values that I'm reading to make sure that what I've written in this script is actually reading through the file properly. And that's one of the things that actually takes a lot of time, is you think you understand how the flow of the format works, but sometimes you'll be wrong, and then you won't be reading stuff correctly. So again, all those assumptions that I was talking about, for instance, when you start, where is it? Right? So when you start here, there's this 0 byte value, this 98, and then a count. But at first I thought it was, you know, these 2 bytes and then those 2 bytes. But then what happens is if I copy this value and go to find, right, and then I go okay, and then I go forward, you actually eventually you get to, is it this? It might be this. You get to a value where the value before it, oh shit, skipped it, where the value, yeah, like this, where the value before it isn't actually a 0. So that was an assumption I made. So I was only ever reading the first vertex strip. But then I realized that no, it's the first time you read the value, you read this one value once for everything subsequent to it, but then you have to read that flag every time you read the next bit of data. So anyway, it's that kind of a thing, like small things that end up breaking it. But basically, you just gotta sit down and figure it out for a long time. But there's a lot of things too, like those constants I was talking about before, right? Those are the Gamecube Vertex flags. And that I have a friend on the Gamecube Forever forum, because I posted some stuff way back when, and he, he's saying like, is the debug vertex attributes, right? Right, so it's just like, it's stuff like that where people point you in the right direction and you start looking at stuff. It's just like a long process of you're trying to guess stuff, and then eventually something pops up, or you think of it in a different way. And it just takes a long time to write all of this stuff, right? Because that's like 1,000 lines of code in this one thing. And then once you've actually read the data, here's another thing. Once you've read the data, you're not done. So this wonderful indent is what's actually drawing it right now in the scene. I have to tell it to do stuff. So if I've read the file properly, at least there's no errors. But then I have to iterate through the data. So I check, well, if the GMA is not null, so like if I've loaded a file, it won't be, then I'll go through each of the models. And then I check, well, if the model isn't null, because maybe I have a GMA, but it hasn't initialized models, it'll skip it. And then if that works, then I'll do this. Temp mesh is a function I've created, and I'll pass in the model, and then that will reconstruct the mesh for the model and display it. But then for each of the vertex strips collections in that model, I'll go through each of the MT strips, so the material strips. And then for each of those, I'll go through each of the vertices in the vertex strips. And then I will debug 3 of them together and draw a triangle, right? So it's just this long of like, hey, if this isn't null, then do this. And then if that isn't null, then do that. And that's why you get like this giant indent. So then code like this gets really hard to read once you've left it for a while, because you're like, what am I even doing? Right? And this is just GMA, and it's not done. Right? So like that's like the general what you do in which order is you open it up, you look at it, you think of stuff, you test it out in code, and then you iterate on your code and you go back in the file and see what it's doing, and then you'll like find something and you'll go research it online and see if you can't get more info out of it. And it's just this constant of like a chase of trying to find the thing that'll help you. But then even then, so I've read all the data, I know all the vertices, I know how they interact for the most part. But then the problem is I start drawing a mesh. So for instance, this purple here, this is a mesh that I'm drawing. But then you'll get this thing, and you're like, okay, well, clearly there's a triangle here because we can see it. but we just see right through it. But if you go on the bottom, it's solid, right? And the reason for that is there's this thing called winding, and it's really annoying. Basically, it's based on which in which order you draw the 3 vertices will tell you in which direction your polygon is facing. So right now, this, for instance, if it's doing it clockwise, then it points up, but if it was doing counterclockwise, it would be pointing down. But the problem is, normally, all of your strips are in sequence. And so what you do is you draw like the first 3 clockwise and the next 3 counterclockwise when you do a strip, and then they'll all be in the right direction. But doing that with this data doesn't actually produce the correct results because these are empty. And there's even a thing where if I go to lightning half pipe, if I go to this stage, oh god, just a second, I'm gonna need to stop this. Cool. All right. So I even have this problem where I'm missing parts of the track. And it draws it for the most part, but I'm still missing stuff. So that means I'm incorrectly reading the GMA. Even though it looks like, you know, I've got most of it down, I don't. So there's some assumption somewhere that in my code is not being addressed. And so I'm skipping over data. Right? And so like the next step really is probably fixing that up. Because I thought, you know, maybe I'm just being dumb and, you know, I don't know what I'm doing and I'm totally missing, you know, some part of the data. But that's not actually true because I went in today and I exported the model out of that old, you know, the 2011 model viewer, and I put it in, and it's like cool, right? Like it's basically it's 1-to-1. Like they're both on the same thing. It's really cool. But then if I stop this, I get this problem right here, right? Where it in the actual export, it works, and then there's this weird strip, and then here, let me add a light. Boom. Okay, right? So same problem, right? Like I come in here and all of a sudden the faces are in the wrong direction. And that's actually because the viewer draws, okay, so there's this thing called backface culling. So what culling is that you don't draw it, you don't render it. Backface culling means that you don't render a triangle from the back, and that's just to optimize it. And so what you have here is it's not being rendered, but in the model viewer it is being rendered, but that's because there is no backface culling in his renderer when you're looking at it. But when you export it, he's not doing that. So then you get this like transparent, there's a gap in here, and you know, you don't know what's going on. But then if you go from the underside, boom, you got, you know, that side that side's working, but you got like this weird thing. And I thought, you know, maybe I was just being weird and I didn't know what I was doing. But then when I go and look at what's going on here, oh, it's locked, that's why. Okay. Right, so if I go to the viewer and it looks like I'm having a problem, so the thing is, it looks like it's doing fine, but it's not actually. So I have, again, that same sort of strip. It's being rendered improperly. If you look closely, you can actually see what's going on. So then if I show you, So I'll put the debug lines up. Right, so you can see it's still got that thing, and it's this weird problem where right, like I can see most of them, and then it goes through, and then it, you know, goes around it. It's weird. It's something weird in the format, and I haven't figured out why at certain points it flips, because that's a real big problem right here, where it's not being rendered, but then it's rendered underneath, like accidentally. But again, then I don't know why that's happening, but then it's not happening on this one, right? But I also don't know why for him, it's not rendering here, right? So it's just like, it's small problems, small things that we haven't figured out yet. Yeah, so that's, I mean, that's this part in a nutshell. And that's what I'm working on, is just like, okay, now that I know most of it, what's, you know, there's a saying that we have that I like, and gave in oh my god, I'm stuttering. So there's a saying in game development that once you've done the first 90%, there's only 90% left. And it's that kind of a thing. Like, sure, you know, it's nice, it's cool, it looks impressive, because wireframes always look impressive, but that's not the end. There's still like more to do and more to figure out. I wonder why that's not rendering. Oh, okay, that makes sense. Anyway, right, so it's just that's that. And like I have another scene in here, right? So this is like another debug. So this is the actual spline data that is used to calculate the collision data for the track. It's done dynamically. So let's grab a good one. Lightning, far field undulation. So I have all of these other things too that will turn on, right? So this orange is quads, quad strips used for collision, triangles used for collision. All of these smaller specks. This is actually a game object in the scene. So here, let me create an empty, right? Like this, right? If I wanted to, here, I could create, you know, sphere, right? And I'll make the sphere, I don't know, 10, 10, 10, right? So this sphere here, if you click on it, you see it's got like this prong thing to tell you the X, Y, and Z coordinates. It's the same thing, but for each one of those, it's referencing a model, right? And that's actually why I'm figuring out the model format right now, because once I have that, I can import all of the models into the scene and actually look at it properly, and it'll help figure out some of the other stuff that's really tricky about this file. Right, and if we go to here, right, like all of these trails, these are like the meteors, because if you go to lightning, they also got that, but it's all for the lightning strikes. And then you got like this weird stuff. Oh my god. You know what? There's a better stage for this. Display track, display spline. Yeah. Okay. So then, oh wait, this is the wrong port 10 aerodye. There we go. Right. So then you get like these control nodes that make these spline paths all curved, and you get like some weird stuff where they're stacked and then reference a lot of things. And I got like a bunch of gibberish set up. Right, but it's just, again, it's that. It's like there's a bajillion bits of data, and I'm just trying to debug it visually so that we can sort of understand sort of what it's doing and why it's there, so that we can hopefully figure it out. Because not even half Not even half is actually just importing all the data. That's probably, it's one of the hardest parts, but it's also, I don't say one of the easiest, but it's like once you properly interpret all the data, it's great, right? Because you actually know what's going on and what's what. But once that's done, you have to write an editor and then an exporter. Not in that order. Probably the first thing that would come up is the exporter. First thing you want to do is import all of the data, and then you would want to immediately export the data again, because then you would like swap it in the actual ROM, and then if it works, then you know that your exporter works. And then what you would want to do is make an editor so that you can import data, manipulate it, or just straight up make your own, and then be able to export it into that format. And then if that still works, then you have a stage editor. But that's the thing. It's just like a ridiculous back and forth. What's this? What's that? And then once you've figured it out, then you're good to go. Right? So just for this, just as an example for that, if I go into, is it data members? No. Yes. Okay, so this script for just scene files is 2,500 lines of code. And that's still not everything. Right? And it's like, it's just this stuff constantly. And that's why it takes forever, is because you'll make assumptions. I get better at code. I'll go back and rewrite something. So it takes 3 days to rewrite it. And by the time I'm done that, I don't have much spare time anymore. Right? And there's stuff like, I have an enumeration of what types of collision do we have, and you know, you start looking and figuring out what's what, and it's just a lot of that. So it's just like a lot of time goes in. So if anyone's interested, I mean, I'm not gonna say no to help, but again, it's just a lot of time. Yeah, I don't know. If you guys have any questions, let me know. Otherwise, I'm supposed to be on campus for 9 a.m. to get some work done on my my thesis project. But hopefully that was a good little like rundown of kind of what goes on. It's not rocket science. It's not impossible. It's just time consuming, and you gotta know a bit of stuff, right? Like once you've done code for a bit, like a lot of this stuff isn't too hard. You'll look at it and be like, oh, that's probably this thing, and then you check it and you're like, oh yeah, that looks right. But yeah. Apparently there's like a 1 minute delay, so I'm gonna ramble for a little bit before I go. Don't save. There's some pretty cool things in here. Yeah. Wireframes always look cool. Huh. That's interesting. I wonder what that is. Because it goes like back and forth. I'm gonna have a quick look. There's oh my god, unhandle exception. my goodness. Just a second. Oh my god. End task. Yeah. There we go. Oh, great. It just went full screen. Yeah, so I just want to, before I go, just want to go check out this interesting thing. Actually, here, let me just show you guys. There's like regular models. The radius is so wrong on so many of these. So these are all like test things. And then you get like these backgrounds. BG, right? So like Mute City has all of these models. Right, and you can flip through and see them. One of my faves. Hologram. Yeah, so anyway, you got all those things. I'm interested in stage 27? No. Stage 24? Yes. Yes. Okay. So where... There you go. That's strange. Doesn't look like there's any property difference between this and what's in the viewer. Unless, who knows? Who knows? Still interesting. But yeah. Basically, I'm just trying to make a version of this in Unity. 35 is the stage. Oh, that's never, it's not fun. This is a final stage. So 31, 30, 36. Yeah. Yeah, there's some weird properties on this track. Oh. Yeah, some things I'll try out at a later date. Oh my god. The viewer is a work of art. Oh my god, fidget spinning. Alright. Oh my god, I'm done. Gotta go to bed. So hopefully next time, whenever that is, I'm actually gonna stream development. So just me sitting down, poking my head at some stuff and just coding. So hopefully that won't be as boring as it sounds. You know, it's a slow thing, but it sort of is what it is. All right, then. I don't know where you people are from, but for me it's almost midnight, so I'm gonna go to bed. Thanks for watching. There's like 9 people, which is quite surprising because I'm just kind of like mumbling for a while. But yeah, cool. All right, I'll try and get good at this thing. No problem. I'll for Optimus What, if ever you have something you want to poke your head at and you don't know what resources, just message me. I'll see what I know. But because like most of the things that I use for this game or other GameCube games, like other people have made them. I'm just like doing the nitty gritty of the actual proprietary formats for the game itself. You know, there's cool stuff in there. But all right then. Bye, I guess. I don't know, I got a webcam. All right. See you guys. Thanks for watching.